All right, guys, so we are taking a look at 6.3 today. So far in chapter 6, we've looked at exponential functions. So that's when um, my base is some number and it's being raised to the power of a variable. So my variable is my exponent. So what 6.3 does, we start to look at the inverse for exponential functions. So we know inverses are kind of functions that undo each other. So if I'm looking at like x squared, I know the inverse is the square root of x. If I have x cubed, I know the inverse is the cube root. So what we have to look at is, well, what is the inverse for an exponential? And the inverse function for an exponential is something called a logarithm. Okay, so we've got our exponential function here that we're looking at. So again, this is on page 164 in your student journal. And we're going to be looking at the inverse function, which is called a log. Okay, so since exponential is dealing with exponents, a log is really just an exponent. So for today, what we're going to be focusing on is how do I go between the two forms? So kind of how do I rewrite something in exponential form and log form, and then the other way around. And then we're going to look at a little bit of evaluating too. So as always, make sure you are taking these notes diligently. You're following through with the examples. And if you don't understand something, make sure you're backing up and watching again or asking a friend. Okay, so we're on page 164 here. And they ask us to find the value of x in each exponential equation. And then I'm going to rewrite this in log form. So let's first think about what the value of x is here. So this is saying 2 to what power is equal to 8. So we all know here that x is equal to 3 because 2 to the third power is 8. Okay, so this is exponential form. Log form would just mean I would have log okay, and a log has two parts. It has the base that goes down below and then what you're actually taking the log of. So notice between these two things, my base is a b, the base of my log is also b. So here my base is 2. Okay, what comes next then is what that actual value is that you're taking the log of. So we say log base 2 of 8 is equal to 3. Okay, so one thing to always remember is that this is going to be equal to the exponent. So this is telling me that log base 2 of 8 equals 3. In other words, 2 to the third power equals 8. Okay, let's try another one. So 3 to what power is 9? Well, I know that if I square 3, I get 9, so I know x must be 2. So log form here would be log base 3 of 9 equals 2 because a log is just an exponent. So it's always going to be equal to the exponent here. Okay, so this piece is asking me what power do I raise 3 to get 9? Well, the answer is 2. So here the question is, what is the exponent? All right, let's just keep going. So if you feel like you kind of got an idea of how this works, go ahead and pause and maybe try the other ones and come back and see how you did. Otherwise, keep watching and we'll go through the next few here. Okay, so this one is saying 4 to what power equals 2? So this one's a little bit trickier because I know like 4 to the first is 4, 4 to the second is 16, and so on. So what you got to think about here is I know the square root of 4 is equal to 2. Or the way I would represent square root with an exponent would be to the 1/2 power. So here x is equal to 1/2 because I know 4 to the 1/2 power equals 2. So when I rewrite this, I would do log. My base is 4 of 2 equals 1/2 because it's always equal to the exponent. So we're just rewriting here, guys. All right, next one, another kind of tricky one. So I have to think about 5 to what power equals 1. So I know that anything to the 0 power equals 1. So here, x is equal to 0. Anything to the 0 power equals 1. So when I rewrite this in log form, I would have log base 5 of 1 equals 0. Okay. Next one here then. So I have 5 to the power of x equals 1/5. So I'm thinking about x is my exponent. What power do I have to raise 5 to get 1/5? So I know to get that fraction, I'm going to need something that's negative. Then I have to think about, well, 5 to what power equals 5, and it's just the first. So in log form here, we get log base 5 of 1/5 equals -1, because my log is always equal to my exponent. Okay, so we are actually going to jump now to page 166, so it should look like this. Okay, so we're going to look at a few different types of logs. So they say logarithm of y with a base of b. All right, so this is just a fancy way of saying log base b of y. So what I want you to start thinking of when you look at stuff like this is really asking you, what power do I raise b to get y? Okay, so that's the question being asked here. So a log is always looking for an exponent. All right, so there are a few types of logs that come up quite a bit, so they have special names. So you can have a base with anything for your log, but the ones that come up the most often would be the common log and the natural log. So the common log means that my base is 10. So this is thinking about powers of 10. So when you have base 10, you can actually just write log of x. So like when there's no base written here, that means it's a 10. So kind of like if you were to have x to the first power, we really only need to write x because we know that if there's no exponent there, it's a 1. It's the same idea. We know that if there's no base there, then it's a 10 because that would be the common log. Okay, the natural logarithm works the same way. So we have seen the number e a little bit when we graphed exponentials. So that's the natural logarithm. As we say, it has a base e. Okay, so this is something that actually shows up a lot in nature. That's why they call it the natural logarithm. Okay, so we say that log, we could write log base e of x, but that's not really what people do. What we do is we write something called the natural log. So they write ln of x. So anytime you see ln, that's a log with a base of e. Okay, so moving down here to the core concepts, this is just looking at that rewriting that we did. Okay, so this is what we wrote based off of this. So this is log form, this is exponential form. So we, kind of our big goal today is getting comfortable going back and forth between those two forms. Okay, so we're going to go over to the extra practice on the next page then. All right, so here they say rewrite the equation in exponential form. So this is opposite of what we did in the beginning. These are all in log form and we want to get into exponential form. So what I first want to look for is my base. I know here my base is 10. In exponential form means I need an exponent. So 10 to the third power equals 1,000. So I know a log is an exponent, so this is always going to be equal to the exponent. I know this is equal to 1,000. So another way to think about it, sometimes people like to do this when they go from log to exponential, is I start here and it kind of loops around like that. Okay, let's look at the next one. So here my base is 5. And I know a log is always equal to the exponent. So 5 to the power of negative 2 is equal to whatever I have here, 1 over 25, which all of these should be true statements. So 5 to the power of negative 2 is in fact 1 over 25. The negative gives me the fraction. The 2 gives me 5 to the second is 25. Next one, so think about looping around here. 10 to the 0 power is 1. Anything to the 0 power is 1. So of course 10 to the 0 power is 1. And the last one here, I'm going to kind of loop around. So I have 1/4 to the power of, and I like to put fractions in parentheses here, negative 3 equals 64. So I know a negative exponent flips my fractions, so this would flip this to make it just 4, and I know 4 to the third is 64. Okay, let's look at the other way around here. So here we're given exponential form, and we want to write in log form. So I'm going to start with my log. And the base of my log is going to be whatever the base of my exponential is. So here that's 12. And I know that a log has to be equal to the exponent, so the 2 is going to be over here. So I want the 144. So this is log base 12 of 144 equals 2. So this is asking me, what power do I raise 12 to get 144? Well, I have to raise it to the second power. Okay, same idea here. So log in my base is a 20 of 1 over 20 equals whatever my exponent is, so negative 1. Okay, next one. So if you feel like you've got this, go ahead and pause and try these and come back and see how you did. So here my base is 216. So log base 216 of 6 is equal to 1/3 because logs are always equal to my exponents. And then the last one, here my base is 4. Of 1 equals my exponent, which is 0. Okay, so that's kind of going between log and exponential form. Now the other thing we want to think about is evaluating. So evaluating is just a fancy way of saying, tell me what this is equal to. Okay, so I'm not given an equation here. Notice the ones we did, we always had an equal sign in. Here we do not. So we want to say what this is equal to. So what this is asking you is 4 to what power equals 64. So sometimes I like to write it like this. So we're thinking 4 to what power is 64? Well, I know 4 squared is 16, and I know 4 to the third is 64. So this is just equal to 3. Okay, so 4 to the third is 64. So this is just asking you for the exponent that's needed to get to your base to whatever you're taking the log of. Okay, the next one. So you do not have to rewrite it like this, but sometimes I do this, especially when we're first learning. So 1/8 to what power equals 1? So here I know that anything to the 0 power equals 1. So this must be 0. So it wouldn't have mattered what that base was. If there's a 1 here, it's got to be 0. Okay, next one. 2 to what power is 1 over 32? Okay, so I got two things to think about. So I have to figure out how to get 2 to 32 and also how to turn this into a fraction. So I know I need a negative exponent to get this fraction. And then I'm thinking about, well, 2 to what power is 32? I know 2 to the 5th power is 32, so this must be a negative 5. Okay, last one here. So 1 over 25 to what power equals 1/5? So you see the fraction, you might think at first, I need a negative, but this is already a fraction, so I don't need a negative to make it into a fraction. So I got to think about how do I get from 25 to 5? So this is one of those kind of tricky ones because the value gets smaller. So I want to think about roots. So the square root of 25 is 5, and I represent a square root as an exponent of 1/2, and a log is equal to an exponent. So this must be 1/2. Okay. Last ones we're going to do here are 13 and 14. So these are actually going to be really important for us in a few sections when we start solving exponential and logarithmic equations. So a lot of times these have things that we can't evaluate. So if I just look at log base 16 of 6 that's in this exponent, I don't know what that is because I don't know what I have to raise 13 to the power to get 6. So I don't know 13 to what power is equal to 6. But remember, this is an exponent that I raised 13 to get 6. So when I raise 13 to that power, I know I'm going to get 6. So I don't know what this number is, but I know when I raise 13 to it, I get 6. So another way to think about this, as long as these match, you just end up with whatever you're taking the log of. Okay? Something that's similar to that then in number 14 here. So this is the natural log. So we talked about this way back here. So that must mean I have a base of e. So what I'm going to think about, if I got my little e. So this is saying e to what power equals whatever I'm taking the base of, or whatever I'm taking the log of, e x to the third. Well, if these both have a base of e, this exponent has to match this exponent. So this is just equal to x to the third. So another way to think about it is as long as these match, this stuff all cancels, and I'm just left with x to the third.